Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, here we go. We're going to do the last lesson of Chapter 1 called Subtracting Probabilities. In our last lesson, we learned about compound probabilities, where you learned that if you want to find out what is the probability of either this event happening or a different event happening, how you would add those two individual probabilities together. And today, we're going to focus on some situations where instead of adding probabilities, we're doing some subtraction. And you may have noticed that in the last lesson, we actually did do some subtracting, and so we're just going to build on that. It wasn't like a focus of the lesson, but it sort of crept in there, and here you'll see it a little bit more. Okay, so in lesson, what's going on? Why don't you go down? Okay, in lesson 1.2.7, you calculated probabilities for single events and combinations of events. Do I want to do that? Hold on for a second. No, okay, I'm not going to go. Okay. With either one outcome or the other is desirable. You have also compared those probabilities to decide which outcomes are more likely or most likely. In this lesson, you will work with your team to apply your knowledge of fractions to represent and calculate the probabilities of a variety of events. As you work today, ask each other these questions to focus your discussion. Okay, well, we know you're not discussing, we're just working on this at home, so think about things in this way. How can probabilities be combined, and how can the answer be rewritten in a different form? Okay, we are back to the stoplight problem because this is a big issue. Knowing the proper steps to add fractions is incredibly important. So here's Eustace adding fractions. 1/2 plus 2/4 equals 3/6. This is one of those questions where not only is Eustace making a common mistake, but you really have to think about the math a little bit. I've said it before in a lesson. I'm going to say it continuously. Math is not something that you can memorize. You've got to understand it. There's just too much to keep track of to memorize everything without thinking about why it works, how it works, and how it makes sense when you do the things the right way. So, I mean, first of all, how do you think Eustace got this answer? 1/2 plus 2/4, pretty obvious, right? Adding straight across instead of finding a common denominator. But the second part is, does it make sense? Why doesn't it make sense? So let's look at this for a second. We all agree that 2/4 and 3/6 are both equal to 1/2. So this statement from Eustace's work is essentially saying that if you take 1/2 and then you add another half to it, you get an answer of 1/2. And it's like, I don't think that's right. So what is going on here that keeps that from making sense? You can't add 1/2 to 1/2 and get 1/2, right? So, oops, stop it. What is going on here? I said, okay. So Eunice, this is what Eunice did wrong. Eunice added straight across instead of putting a common denominator. And just the fact that the answer 3/6 is equal to the first addend. It's like if you said 1/2 plus 0 would equal 3/6. Okay, we could accept that, but not 1/2 plus 1/2. So let's correct the problem. Go ahead and write this problem down and figure out what the correct answer is. I think you can tell pretty obviously what it's going to be right there. Right? You start with your fraction 1/2 plus 2/4. And if you wanted to solve this problem by finding a common denominator that was the least common denominator, you could change 1/2 to 2/4 and say 2/4 plus 2/4 is 4/4, and we know that 4/4 is equal to 1, correct? So our answer's got to be 1. If you had chosen to use the coat of arms instead of just finding the least common denominator, you may have chosen to write 4/8 plus 4/8, right? Because 4 times 1 is 4, 4 times 2 is 8, 2 times 2 is 4, and 2 times 4 is 8. So we've rewritten 1/2 and 2/4 both as 4/8. Add them together, you get 8/8, and the 8/8 is equal to 1 as well. So it really doesn't make any difference which strategy you use. Just choose one. And does that make sense? Yeah, 1/2 plus 1/2 is 1 whole. Yeah, we know that. Okay. All right, so let's focus on this. Lindsay has a paper bag full of Fruity Tooty Chews in 3 different fruit flavors. She says if you reach into the bag, you have a 1/3 chance of pulling out a killer kiwi. So I just wrote this down, probabilities. Killer kiwi, 1/3 probability of pulling that out of the bag. There is a 3/5 chance that you get a crazy coconut. All right, so I'm going to do a little analysis here on the side. Just thinking about this before we start doing any work. I'm thinking, all right, so we know the probability of killer kiwi is 1/3, and the crazy coconut's 2/3. So if we're going to answer the question, what's the probability of pulling out either a kiwi or a coconut? Don't you have to add those 2 probabilities? That's what we learned yesterday. So we would want to get common denominators and add those together. So to answer this first question, if you reach in the bag, what is the probability of pulling out either the coconut or the kiwi flavor? That would be 11/15, because it's the sum of these 2 probabilities, because we use the word or. All right, so does there have to be another flavor in the bag? How can you tell? Well, what does this number represent right there? Isn't that not a complete bag, right? It's 11/15. The complete bag would be 15/15. So if this was like 7/15 and that was 8/15, the total adds up to the whole, then there would just be 2 flavors. But the fact is, there's something left over there, right? So how much is left over? There's got to be 4/15 some other candy in there, whatever that flavor might be. So that's the third candy's probability is 4/15. So now, how many candies might be in her bag? Is there more than one possibility? We did something like this the other day, and yeah, the number of candies in there would be like the common multiples of your denominators. Your 3 and their 5, so there could be 15 in there. In which case, 5 of them would be kiwi, 9 of them would be coconut, and is that right? No, hold on. Let me rephrase it. 5 of them would be kiwi, 6 of them would be coconut, and the rest of them would be the next flavor. Or there could be 30 in the bag. It could be 10 of them, 10 of these, 12 of those, and then 8 of these. There could be 45, so there would be 15 kiwi, there'd be 18 of the coconut, and 12 of those. But any multiple of 15 basically could be the number of candies in that bag. All right, Lyle asked for a challenge problem because that's how Lyle is, and his teacher gave him this one. There is a 2/7 chance of drawing a red marble out of a bag of marbles. So I'm writing this over here for my probabilities. You should record this too. The probability of pulling a red is 2/7. That's what it says right there. If the probability of drawing a red or a marble is 2/3, what's the probability of drawing a marble? Okay, so now we're going to have to do some reverse thinking, right? We know red is 2/7 probability, and we know that the combined total of red or blue would be a 2/3 probability. So how can you back that up and figure out, okay, what's the probability that you would add to the 2/7 to give you 2/3? So Lyle's teammates saw this as a challenge, and they decided to come up with some ideas for this. Myra says that he should start by getting a common denominator, right? Myra suggested that he start by rewriting 2/3 and 2/7 so that they have a common denominator. Because remember, compound probabilities involved us doing some addition, right? And before you can add fractions, you gotta have a common denominator. Vanessa, she's like, no, this is a subtraction problem. What you need to do is set it up so you say 2/3 minus 2/7 is going to give you your answer for blue. And Darren's like, no, I got a different idea altogether. The probability that you would draw either red or blue is the same as the probability of drawing red added to the probability of drawing blue. So he wrote his equation like this. And you're like, yeah, great. Really circled the horses, circled the wagons around this problem because all of them are correct. You do need common denominators because you are working with fractions. It is a subtraction problem eventually, but it starts off as an addition problem. 2/7 plus something will give you 2/3. That's how compound probability involving the word or works. So in order to figure out what that is, it's kind of like this problem here. Let's just take 2 plus n equals 3. You know that you're going to add 1 to the 2 to give you the 3, but to show that process, you would actually show that you would take 2 away from 3, which would leave you with your value for n. So 2 plus 1 is 3. We're going to have to do the subtraction, and that's how you're going to solve that problem. So go ahead and solve that problem. Get your common denominators and see if you can figure out what the probability of getting a blue is. Go ahead and pause, work through that process, and unpause when you're ready to move forward. Okay, so we're going to say that you are ready to go. So this is basically what we're going to do. We have to take the 2/3 minus the 2/7 to figure out what the probability is. So we'll get a common denominator. And once we get the common denominator, 14 minus 6 is 8. So our probability for blue has to be 8/21. Now, it's always a good idea to check our answer to make sure that this is correct. Remember, the probability of getting red was equal to 2/7, and now you're saying that the probability of getting a blue is equal to 8/21. So if we add those together, we should get 2/3 for the combined total for the compound probability. Okay, so let's go ahead and do that, and I think 21 should be our common denominator. So I'm going to multiply that times 3/3 and make this 6/21 plus 8/21 equals 14/21. And when you simplify 14/21, 14/21 is the same, what is this, 2 times 7, and this is 3 times 7. So when you cancel out, sure enough, we got our 2/3. So we can feel confident that we've got the correct answer. All right. Thinking about that process of using subtraction to figure out the final answer, Louise is playing a game, but the spinner's incomplete. Will you please draw this spinner, do your best to get all of those wedges fairly close to the way that this is shown right here, and you can label this wedge is 2/5, this is 1/6, this is 1/3. What is the missing fraction? I'll give you a hint. The whole circle represents the number 1, right? The whole, if you combine all of them, they have to add up to one whole circle. So what we're going to be doing is figuring out what the missing piece is eventually by doing a subtraction. So pause, see if you can figure out what that missing fraction is. Unpause it when you're ready to follow along with me. Okay, here we go. Let's see what this first box uncovers. The first thing we need to do is add them together. Now, I chose to add the 1/3 and the 1/6 together first because it looks pretty obvious that that's half, right? And by the time you do that, 6 plus 1/6 is going to equal 1/2. So now we're going to add this half to this 2/5, and our common denominator should probably be a 10, correct? So 5/10 plus 4/10 is going to give us a total of 9/10. So what do you add to 9/10 to give you 1 for an answer, to give you 10/10? Maybe I'll go ahead and just change that right now to make it a little bit more obvious. Oh, okay, we can have it. No. Yeah, we can have it in red, whatever. No, we can't. OCD taking over, making it blue. The world is right again. Okay, so 9/10 plus something equals 10/10. Absolutely. The missing probability of that section is 1/10. Does it look like it could be about 1/10? If you broke this up into 5 equal parts and that into 5 equal parts, then there'd be a total of 10 parts, and that looks like, yeah, that's pretty close to 1/10 total. All right, so there you go. That's the process. Let's go ahead and do it again. Copy down. This is the last problem. We're going to be done quickly today. I could feel it. We're going to be less than 18 minutes. I'm certain of it. All right. So Charlie found a spinner that his teacher was making. He knew that if he put his problem-solving skills to use, he could be able to figure out the missing piece. Okay. So what is the expression that we would work on here, right? What eventually we did in the previous problem was we added up all of these parts and then we subtracted it from 1. So that's kind of the expression that we're going to use here. But you got to find the total sum of all of these first before you do the subtraction. And if you like me and instead of doing a subtraction, maybe you like to think about counting up method for subtracting, right? Instead of 10 minus 9, you just think, well, 9 plus 1 is 10, so this has to be 1/10. You can think of it that way too. Okay, so go ahead, put it on pause after you've drawn everything in and go ahead and figure out what is the missing probability. And let me just tell you, please don't guess. Don't say, oh, that looks like it's about 1/12. I'm going to say it's 1/12. Okay, that's a random guess. Just because they drew the wedge and it looks like it might be 1/12, it might be 1/15, it might be 1/18. How do you really know? So do the work. Prove that your answer is correct by showing all of your work. Okay. When you're ready, unpause and I will walk you through it. Okay. First off, what we're going to do is we're going to take that expression and we need to start doing some simplifying. So I notice right here you've got this is 1/2, right? So let's just rewrite 1/4 plus 1/4 as 1/2. So then we're going to add them together, and 2, the 8, and the 3. I feel like 24 is a good denominator because 24 would be the least common denominator of 8 and 3, and 2 goes into 24, so we might as well just go ahead and rewrite those. So 1/2 is 12 over 24. 1/8, since you multiply 8 times 3, you'll have to multiply 1 times 3, so it's 3/24. And the same thing here, and you can think of your coat of arms if you want to as well. 3 times 8 and 1 times 8 gives you 8 over 24. So 12 and 8 makes 20, plus 3 makes 23. So what is 24 over 24 minus 23 over 24? It's 1 over 24. So that missing section ends up being a 20. Hey! What happened? Ends up being 1/24. Okay. So situations like this, it actually popped up in the last lesson, like I told you. Sometimes you're adding, sometimes you're subtracting, because adding and subtracting are opposites of each other. They're inverse operations. So often, any kind of a skill that requires you to do some addition to solve may require you to do some subtraction as well, depending on what pieces of information you've got and whether or not you got to do some algebraic reasoning. Okay. All right, so good job. We are going to transition for a few days into review for Chapter 1, and then we're going to take our Chapter 1 test and see how well you remember all of these concepts. Good work, good luck on the homework, and good luck on the study guides, and good luck on the test.
Hey, feeling good, like I should.